So this is an intentionally challenging problem you haven't really seen before and haven't really seen an example of. So I'm going to kind of give you a hint example to get you started, particularly on how to find the equation. And then from there, everything else is kind of the same as what we've done before. But this table is a little bit different where our x is going up by 2 each time. All right, so notice that this is plus 2, plus 2, plus 2, and plus 2. Now, just like what we do before, I might start off with, here I go plus 3, and then it quickly flips to minus 3, minus 3, minus 3. So just like what we did before, we can find our vertex where the plus becomes minus, negative 16, 13. Now, what's different is the slope is going to be a little bit, so you could just kind of put your vertex in like that, right? The opening up and opening down is the same, right? If we look at this 13, we see that 10 on each side is getting smaller, smaller, and smaller, smaller. So in this case, we're going to be going down. And so down meaning it's probably going to be a negative slope or a negative what our slope is. But just like with a line, right? It's not that different than the line. See on this side, even though it's positive and negative, in this case it's 3. That means our y values, remember, rise over run, which is, our x's over, or our y's over our x's. So our rise in this case is 3, and then our run is 2. So it would be 3 over 2. So this is the equivalent of our slope. So in this case, we have a fractional slope. Now you can use, once again, the slope, that it's going down, and the vertex coordinate to create the equation. Once you have the equation, everything else works the exact same. Finding the y-intercept's the same, x-intercept's the same, line of symmetry, domain's always the same, range, everything else is the same. So good luck.